For years, packaging applications into isolated environments was an external operational chore. Developers had to step away from their code to write manual Docker files and manage base OS updates just to get an app ready for production. .NET 10 changes that workflow. Microsoft has integrated containerization directly into the SDK, making it a native capability of the development environment. You can now build and package a standard web application into a container without writing a single line of Dockerfile boilerplate. The SDK handles the heavy lifting. While this removes the initial barrier to entry, it introduces a different challenge, a paralyzing choice between 9 different deployment directions. This graphic shows the current landscape. From the central .NET 10 SDK, there are now 9 distinct container publishing pathways routing out to various cloud deployment targets. To navigate this, you have to narrow your focus. Selecting a path that doesn't align with your team's workflow often leads to unnecessary infrastructure code or a deployment pipeline that is difficult to automate at scale. Every architecture decision here comes down to one core trade-off: frictionless integration versus granular operational control. To simplify the choice, we can group these 9 strategies into 3 specific team scenarios. Matching the deployment tool to your team's specific archetype helps prevent the accumulation of infrastructure friction as your application grows. The first scenario is for solo developers or small, agile teams. Your priority is shipping features quickly with 0 configuration deployments, bypassing traditional Docker files entirely. This quadrant chart maps setup complexity against operational control. SDK native container publishing sits in the low complexity zone because it treats the container build as a standard part of the MSBuild process. A single terminal command compiles the code and generates the image. When you pair that with the Azure Developer CLI, or AZD, you can push those 0 config containers directly to a cloud registry without leaving your terminal. For standard line of business applications, this means achieving high deployment velocity with almost no infrastructure overhead. The trade-off is control. By relying on the SDK, you sacrifice the ability to customize the base operating system image layer by layer. This frictionless path accelerates development. However, if your application requires specific native libraries or OS-level dependencies, this default approach will not be sufficient. Now we shift to the Enterprise Security Engineer. This is a regulated environment where you cannot rely on automated default images and require strict, auditable compliance. Looking back at our chart, these requirements move us into the high-control quadrant. Here, teams maintain traditional Docker files, but often swap the Docker engine for Podman to gain more flexibility in their security model. The primary security benefit of Podman is its daemonless, rootless environment, which satisfies strict enterprise compliance requirements. This path introduces a steeper learning curve for developers accustomed to Docker Desktop and requires DevOps teams to refactor pipelines. For heavily restricted environments, .NET 10 includes a Tarball Export feature, sitting at the high end of our security axis. Instead of pushing an image to a live registry over a network, Tarball generates a complete container image archive as a local file. You trade developer convenience for the ability to support air-gapped network architectures, where a live registry connection isn't an option. Our final scenario involves massive, high-scale enterprise architectures that are responsible for managing thousands of individual microservices seamlessly across multiple different cloud providers simultaneously. Back on the quadrant chart, we reach maximum scale. This level requires Kubernetes, Helm, or Konet to manage deployment state. This provides repeatable enterprise deployments that behave identically whether running on Azure Kubernetes Service or Amazon EKS. This architecture requires dedicated DevOps expertise and creates significant infrastructure management overhead compared to simple container hosting. At this scale, compute efficiency translates to lower cloud bills. Architects often optimize their containers by compiling applications with native AOT, or ahead-of-time compilation. Pairing native AOT with AWS Graviton processors reduces image size and provides near-instant startup times, which lowers total compute costs. But native AOT comes with strict trade-offs. Build times increase, and if your code relies on dynamic reflection, it will fail at runtime. This path offers the most efficiency for high-traffic environments, but for a standard internal web app, it is an expensive over-engineering trap. .NET 10 does not force you into a single paradigm. It provides a spectrum of choices to match your specific team capabilities. For startups needing rapid deployment, the frictionless path with SDK Native and AZ is most efficient. In regulated industries needing air-gapped security, Podman or Tarball exports provide necessary control. And for multi-cloud scale, Kubernetes with native AOT offers the highest performance. Actively evaluating these trade-offs is a critical step in keeping your infrastructure complexity aligned with your actual business needs. Align your .NET 10 deployment tooling with your team's operational maturity rather than chasing the newest infrastructure hype.